Hello, thank you for watching this video. So in this video, we're doing question 6 of November 2023 question paper mathematics paper 1. So this is financial mathematics. So I'll read question 6 statement and then proceed to answer the questions that follow. So 6.1. Patrick deposited an amount of 15,500 rands into an account earning AR% per annum compounded monthly. After 6 months, his balance was 19,319 rands 48 cents. So that's the statement. So our friend Patrick deposited 18,500 rands into an account earning R% per annum compounded monthly. After 6 months, his balance was 19,319 rand 48 cents. That's what they're saying. So 6.1.1. What are they saying? They are saying calculate the value of R, right? So what are you given? You are given that the person deposited a principal amount of what? Of 18,500 rands into an account, and then this 18,000 accumulated to what? 19,000 rands, 319 rands 48 cents. So it accumulated to this amount. After the period, number of years is half a year, because it's 6 months, right? That's 6 months of yours. It's half a year, and the interest rate is R%, right? That's what they give you, which is more like what? It's R. And the compoundings are what? It's monthly, so there's 12 months in a year. So we are told that our friend invested 18,500 into a savings account, and then that savings account accumulated to 19,319 rand 48 cents over a period of 6 months or half a year, and it was compounded at R% per annum compounded monthly. So they're asking you, what is the interest rate? So you know that A is equal to P to 1 plus I over M raised n M, where n is the number of years and M are your compoundings, right? So you're given that the accumulated amount is what? 19,319 rands 48 cents is equal to the principal amount. What is the principal amount? The initially invested amount, which is 18,500 into 1 plus 0.0. Oh, actually, you don't have the interest rate, so it's R over what? Over 12 raised n M. What is n? N is half a year, right? Number of years times M, which is 12. Which is 12. That is those are your compoundings. Then you solve for R, straightforward. So what do we do? Divide by 18,500 both sides. Divide by 18,500 both sides. So this and that go away. So you're left with what? Let's punch that. What is 19,319 rand 48 cents? Divide by 18,500. Came up to be 1.0443, let's say, is equal to what? 1 plus R over 12. This times that is 6. So what do we do from here? You take the 6th root, you take the 6th root. So this and that go away. On the right hand side, we're left with 1 plus R over 12 is equal to, what is the 6th root of this? Sixth root is 1.0072 5. Then transpose the 1 to this side. So it will, you will be left with 0.00725, right? It's equal to R over 12. Cross multiply, solve for R. Multiply by 12. So your R so you have 0.00725 times 12. What do we have? We have R is equal to 0.087, which is equal to what? 8.70% per annum, compounded monthly. Done. Looks like this. Straightforward. You wish they give you questions like this all the time. So let's go to the next one. 6.1.2. What are they saying? They are saying now 6.1.2, calculate the effective interest rate. So they want to calculate the effective interest rate. So the ones that you do at grade 12 that you're dealing with is effective, right? Effective interest rate. So, and a nominal interest rate. So you deal with those two. What is an effective interest rate? So an effective interest rate is a type of interest rate where the quoted interest and the compounding periods are the same, right? So I'll give you an example. Let's say I'm saying that I'm giving you, this is an example, right? I'm giving you a percentage of 12% of, let's say you have an account that earns an interest rate of what? Of 12% per annum. Compounded. Compounded what? Compounded annually. Right? So you have that account, or maybe an investment that earns this interest rate of 12% per annum, compounded monthly. So here is your interest rate, right? It's 12% per annum. What is the, which is you will earn 12% per year or over a year, right? And to be compounded annually, which means you will gain interest at the end of the year. An effective interest rate is the type of interest rate where the quoted interest rate and the compounding periods are the same. So look at this example here, the second one. Let's say now 12% per annum, right? Compounded quarterly. So if you look at this one here, it's 12% per annum, right? Which means you'll get 12% a year, compounded quarterly, which means you'll be getting that interest, that 12% will be spread out over quarters of the year, which is 4 quarters of the year. So you can see that the compounding period, like the quoted interest rate and the compounding periods are different, because there you'll be getting 12% per annum, but over what? Over quarters, which is not the same as your year or that annum. So this is an example. Here, what we have here is an example of an effective interest rate, because this is an example of an effective interest rate because the quoted interest rate and the compounding period is the same, right? But here, the quoted interest rate and the compoundings are different. So this is an example of a nominal interest rate. So here we are asked to calculate the effective interest rate, but just to define it, an effective interest rate is the one in which the quoted interest rate is the type of interest in which the quoted interest rate and the compounding periods are the same. So 12% a year, and you'll get that at the end of the year, right? That interest rate of yours. But here it's 12% a year, but you'll get it over, that 12% of yours is spread out over the quarters of the year, 4 quarters of the year. So your quoted interest rate and your compounding periods are different. So that's the difference between these two interest rates. So they wanted to find the effective interest rate. So to find the formula for that, you say 1 plus I effective, which is what we want to calculate, is equal to 1 plus I nominal over your compoundings raised by your compoundings. Right? So say 1 plus I effective, which is what we want, is equal to 1 plus I nominal. So the nominal interest rate that you're given actually is the one that you calculated here. Say 8.70 per annum compounded monthly. You can see that the quoted interest rate and the compoundings are different. Hence why it is nominal, which is what I was explaining there. So you're given, you have calculated the nominal interest rate down here. So we want to find the effective. So to find the effective, say your 0.087 over 12 raised 12. Right? So you solve for I. So I effective is equal to what? 1 plus 0.087 all over 12 raised 12 minus 1. Then your I effective is equal to the answer of that. So let's punch that and see what we get. So we have 1 plus 0.087 over 12 raised 12 minus 1. So you get that you have 0.09055, right? Therefore, your rate will be times 100. It's 9.06, right? Percent per annum. Compounded, what? Annually. Because this is the effective interest rate, right? This is the effective interest rate. So the quoted interest rate and the compounding period should be the same. So this is what we have. That is your effective interest rate. So we're done here. Go to 6.2. What are they saying? They are saying Kuda bought a laptop for 10,000 rands on 31 January 2019. He will replace it with a new laptop, with a new one, in 5 years' time on 31 January 2024. Okay. So, what are they saying? They're saying our friend Kuda bought a laptop for 10,000 on 31 January 2019. They are saying he will replace it with a new one in 5 years' time, right? On 31 January, or on 31 January 2024. So, what are they saying? 6.2.1. This is the first question. Okay. They are saying the value of the the old laptop depreciates annually at a rate of 20% per annum according to the straight line basis. So they are asking, after how many years will the laptop have the value of 0 rands? So what are they saying? They're telling you that our laptop depreciates annually at a rate of 20% per annum, right? On a straight line method. They're asking, after how long will the laptop have no value? So you are told that our friend purchased this amount, this laptop, for 10,000 rands, right? And then we are told that this thing depreciates, right, on a straight line basis. So straight line method have this formula, 1 minus IN, right? So they are asking you, how long will it take for this thing to have a value of what? Of 0 rands. Want this to have no value. So you want to know how many years it will take to depreciate to this amount if the rate of depreciation is 20% per annum, right? Which is 0.2. So how long will it take for this amount to depreciate to that? That's what they're asking. So what do we do? So we say, okay, we have the formula, our A is 0 rands, is equal to P, which is the purchase price, which was what? 10,000. 1 minus I, what is I? 0.2 N. Right? So divide by 1,000 both sides, 10,000 both sides, 10,000. This and that go away. This is 0. So 1 minus 0.2 N is equal to 0. So 1 is equal to 0.2 N. Right? So divide by 0.2, divide by 0.2. So this is 0.2 is like 1 over 5. Therefore, your N is equal to 5 years. So this laptop will take 5 years to depreciate to 0 rands, for its value to depreciate to 0 rands. So this one is pretty much straightforward. So we'll move on to 6.2.2. But it seems like I will need space, so I'll clean the board and then we go there. So I'll clean the side. So now we move to 6.2.2. They're saying our friend Koda will buy a laptop that costs 20,000 rands. In order to cover the cost price, he made his monthly deposit into a savings account on 28 February 2019, which means 1 month after he purchased the new one. He will make his 60th deposit on 31 January 2024, right? The savings account pays an interest rate of 8.7% per annum compounded monthly, right? They're saying now, calculate Koda's monthly deposits into this account. So let me read this again. 6.2.2. Koda will buy a laptop that costs 20,000 rands. In order to cover the cost price, he made his monthly deposits into a savings account on 28 February 2019, which is 1 month after he purchased the new laptop. He will make his 60th deposit on 31 January 2024. The savings account pays the interest rate of 8.7% per annum compounded monthly. Calculate Koda's monthly deposit into this account. So, what are they saying? So, I will try. This one is the easiest. There's no need for a timeline, but I will draw it just as a practice. So, this is the beginning. Here, this is 31 January here. And which is 2019 here. 2019. Up here at the very end. What is the time here? So at the very end, he will make his 60th deposit on 31 January 2024. 31. So this is 31 Jan 2024. This is this time here. So his first deposit was actually not his first. This is when he purchased the new. This is when he purchased the new laptop. Then 1 month later, here, this point here, I would say it's 28 February 2019 here. This is when he made his first deposit. His second deposit will be made here, that is end of March. And then he continued until here. So he'll be making his 60th deposit there. So our friend here started adding money here, whatever the amounts that he was adding, up to here. So in total, he made 60 deposits into the account, right? So they want us to find the monthly deposits. So you want to find, okay, so we want to find how much amounts he must pay into that account to have a future value of 20,000, which is the cost price of the new laptop that he is wishing to buy. So we know that the future value of this investment, is equal to 20,000 rands, right? And this account is earning an interest rate of 8.70% per annum, compounded monthly. This is the nominal interest rate, because see the quoted interest rate here per annum, but you are earning interest per month. So the quoted interest rate and the compounded periods are not the same. So this is a nominal interest rate. And you know that the number of payments to be made is 60. So you know the formula for future value and your compoundings, of course, 12. Future value is equal to what? X into 1 plus I over m raised n minus 1 all over I over m. This is a formula for your future value, where n is the number of payments, right? This is your future value. You know how much you want in future. He wants to have 20,000 to purchase the new laptop. You want to know how much he'll be paying, right? So you have 1 plus 0.087 over 12 raised 60 minus 1 all over 0.087 all over 12. Therefore, you want x, which is this amount, to be this times that. So your x is equal to cross multiply this times that, which is 20,000 times 0.087 all over 12. Then you divide by that. Divide by 1 plus 0.087 over 12 by 60 minus 1. Therefore, your x will be whatever the amount that comes out of this. Let's go. So, what is it? So, it will be 20,000 times 0.087 over 12 divided by 1 plus 0.087 over 12 all raised 60 minus 1. So the amount that our friend will be paying to this account will be 267 rands 26 cents. So these will be the monthly payments for 60 months or 5 years. He will make the monthly payments of 267 rands 26 cents for 60 months in order to have 20,000 at the end of 5 years. Done. So we'll move on. 6.3. 6.3. Tino wins a jackpot of 1.6 million. He invests all his winnings in a fund that earns an interest of 11.2% per annum compounded monthly. He withdraws 20,000 from the fund at the end of each month. His first withdrawal is exactly 1 month after his initial investment. How many withdrawals of 20,000 will Tino be able to make from this investment fund? Okay, so they're saying our friend Tino here, he won 1.6 million from a lottery jackpot. So he invests this 1.6, all of it, in an account that earns an interest rate of 11.2% per annum compounded monthly. So he withdraws 20,000 at the end of each month, right? And his first withdrawal is made exactly 1 month after he started his investment. So they are trying to find how many 20,000 withdrawals will he be able to make from that investment. So how many 20,000 he will be able to withdraw from that investment of 1.6 million. So here we have the present value of this investment to be 1.6 million, right? So we want to know how many withdrawals he'll be able to make, but we know that he will be withdrawing how much? 20,000 each month, right? And we know the interest rate is what? We know that the interest rate in this account is 0.112, and the compoundings are what? The compoundings are 12. So you know that the present value is equal to x into 1 minus 1 plus I over m raised negative n all over I over m. So you know almost everything except for what you want, which is the number of things there. So present value 1.6 million is equal to what? These are your monthly withdrawals of 20,000 into 1 minus 1 plus 0.112 over 12 raised negative n all over 0.112 over 12. What do? We cross multiply actually. So this times that, so you will have 1.6 million, right, times 0.112 over 12, right? Then once this one is gone, you're left with this. Divide by 20,000 is equal to 1 minus 1. 1 minus 1 plus 0.112 over 12 is negative n, right? So you transpose this guy to the side, this guy, all of it, and transpose this guy to the other side. So what do we have? So we'll have 1 plus 0.112 over 12 raised negative n is equal to what? Equal to 1.6 million, right? Times 0.112 over 12. Actually, no. It's equal to 1 minus 1.6 meter times 0.112 over 12, all divided by 20,000, which is what we have here, right? Because, yeah. Then from here, things are straightforward. So I'm going to use this space down here. So what do we do? This space will not be enough. I will clean the whole side. We're trying to solve for n here. So let's solve for our n. So what do we have? So we have 1 plus what? Plus 0.112 over 12 is negative n is equal to what? It's equal to 20,000 minus 1.6 million, right? Times 0.112 over 12, all divided by 20,000. So I just simplified this thing, or you can punch it. So from here, what do we do? You can say 1 plus 0.112, right? Over 12, then make this one positive, right? And then swap these to compensate for that. So you have 20,000, all divided by 20,000 minus 1.6 meter times 0.112 over 12. right? So we can punch this and punch that. So 1 plus 0.112, 12. Looks like we have what? 757 over 750 raised n is equal to punch that as well. So you have 20,000 minus 16123 times 0.112 over 12. You get, this is what? 75 over 19. 35. Then from here, take the log of this side, take the log of this side. So you have n natural log of 757 over 750 is equal to the natural log of 75 over 19. So how do we get this? So when you apply the natural log, this n comes to the front, right? You know logs. Then divide by log of 757 over 750, divide by natural log of 757 over 750. So this and that go away. So the number of payments will be the answer to that. What do we have? We have natural log of 75 over 19 over natural log of 757 over 750. So what do we get? Get 147.80. So this is the number of payments. Oh, this is the number of withdrawals that our friend will be able to make into that account, from that account, or from that investment. So this is all of question 6. So our friend will make a total of 147.8 withdrawals into that account. So, or maybe 17. Number would be more like 148 withdrawals. So I think this is the final answer. I hope this question was clear to you as it is to me. Thank you for watching.